Hello, everyone. Mr. Minix, my name. Math is my game. And today, in this lesson that my fifth and sixth and seventh period classes are going to hear, and it's the only video that they'll get this week. It's a short week. Anyway, factoring review. Factoring review. I said last week, if you recall, that to do the stuff in Chapter 5 that we're doing, you have to know all the stuff from Chapter 4. And part of that, two sections of it was factoring. So today, what we're looking at are all these different bullet points of factoring. Greatest common factor. How do you factor one of those out? And that's the first example of 9 that we're going to get to. The next example, factoring a quadratic trinomial when our a value is 1. Something like x squared plus yada, yada, yada. Something that factors. Okay, something where the coefficient of the quadratic term is the loneliest number that you'll ever do. Okay, in theory, those ones are easy. Those are the ones that most people should be able to factor pretty handily. The next one then is when a is not 1. When a is not 1, something like 6x squared plus something, something, something. Okay, those ones get a little bit more challenging to factor. The next kind that we'll be looking at is quadratic-like, or what I like to call quasi-quadratic. Something that's going to factor like this, but instead of being x squared, it's going to be x to the 4th, or x to the 6th, or x to the 8th. You know, something like x to the 4th plus 5x squared plus 4, something like that. Okay, and those actually aren't so bad to factor. Factor by grouping, probably one of my favorite techniques. Factor by grouping. It's when you have 4 terms, x cubed plus 5x squared minus 2x minus 10, something like that. That green, I don't know if that green's going to show up. It's a pretty bright color. The next two are special cases. I used a triangle to talk about those. Difference of 2 squares and the perfect square trinomial. You know, it's been a minute since we talked about those. And then the last one, something new. So anyway, that's a roadmap of where we're heading today. And I hope that everybody's ready. It's a Monday, or Wednesday. It's kind of a weird day. Speaking of weird, food combinations. I don't know. I like to talk about food. I like to think about food. One thing that you owe it to yourself to try, and I probably mentioned this before, is if you go to a restaurant sometime and you're really hungry. I mean, so hungry that like anything that comes before you, like the breadsticks, you're just going to gobble them all up. Don't get your entree first. Don't eat the breadsticks. Hopefully it's at a place that has nice desserts. Order your favorite dessert. Get a nice cup of mocha coffee with it, or a milkshake, or some kind of a rich drink to go with it. When I say rich, I mean sweet, tasty goodness. And enjoy that dessert. When you eat that, it's going to taste like heaven. Let's think about a restaurant. I don't know if I've gone through this before. You go to a restaurant and you're hungry. What do? You eat the breadsticks. You eat 9 breadsticks. And then your Hawaiian punch comes out and you're thirsty from eating all those breadsticks. So you drink 3 glasses of Hawaiian punch. Your salad comes out. It's got your favorite dressing on it. You take 2 bites of it. You're like, man, I need a breadstick to wash this salad down with. So you eat a 10th breadstick. And then your entree comes out and you didn't even finish your salad. And you were really hungry and you just filled up on those crappy, cheap, day-old breadsticks. Anyway, next time you're at a restaurant, trust me, dessert first. It'll change your world. I don't take credit for that. Example 1, factor. So on this one, there's a couple things going on. Number 1, it's a polynomial, cubic polynomial. Number 2, it's not in standard form. So we probably ought to put the thing in standard form first. So that's going to be 9x cubed. Take away 3x squared plus 6x. So what I notice about this right off the bat Sorry, I got a frog in my throat. I'm thinking about that. I'm thinking about the pie that I had yesterday. Anyway, I'm looking at this term, I'm looking at this term, I'm looking at this term, and I'm noticing that all of them are green. What else do we notice about all of them? What common factor they have? They're all divisible by 3. And there's something else that they're all divisible by. X. So our GCF in this case is 3x. Do you need to make a side note of that? Not really. You just need to factor it out. And when you factor it out, what that means is setting it in front of whatever you're going to have. It does have to be in your answer. It does have to be a part of your answer. And so we're going to divide each term by 3x, starting with the first one. So we divide 9x cubed by 3x. 9 divided by 3, of course, is 3. X cubed divided by x is x squared. So that's going to leave 3x squared. Moving on to the next, we divide negative 3x squared by 3x, and that's going to make, what's that going to make? 3 cancels with 3. X squared divided by x is going to be x. So it's going to be minus x right there, right? So minus x. And then on the end, we're going to have 6 divided by 3, which is going to be 2. And x divided by x, the x's cancel, so that's going to be a 2, and it's plus 2 or minus 2? Plus 2. Now we could stop there. The directions just say factor. Maybe the directions should have instead said factor completely. I gotta make a confession. I dreamt up this example this morning. I don't know if this factors any further, but it might. It looks to me like it does, because 3 times 2 is 6, and 6 has factors that add up to negative 1. What I'm getting at is 3 times 2 is 6. 6 has factors that add up to negative 1. I'm thinking that trinomial that I ended up with, I'm thinking that there's a high probability that that's going to factor again. And if it does, to answer this question as best as I can, I have to factor completely. Entirely. Factor until no more factoring can be done. So in my answer, I'm still going to have this 3x out front. And on one like this is factoring when a is not 1. So this is a good chance to show you several techniques, several ways of factoring this. Probably my favorite, especially in this case, is guessing and checking. Guessing and checking. I know that these first 2 terms are going to have to be 3x and x. 2 is prime. It's the only even prime number. So there's really not much else to do on this one other than to figure out if the 2 goes here or the 2 goes here. Interesting. If I put the 2 here, my outer product of the trinomial is going to be, if I put the 2 over here, it's going to be 6x, and I'm trying to come up with a 1x in the middle. So I don't think I'm going to put the 2 there. I'm going to try to put the 2 here. I'm going to try to put the 1 here. My signs in that trinomial are minus plus, which means the signs both have to be minus. The signs would both have to be minus. So this would have to be a minus, and this would have to be a minus. This is going to make minus 2x. This makes minus 3x. Those don't add up to minus x. So all that work was for nothing, and it doesn't factor any further, and we're done. But I had to check. I had to check, because it could have. It may have. It didn't, but it may have. It's kind of like wearing your seatbelt. I don't know if anyone has ever been stopped by the police at a random checkpoint. Maybe you wear your seatbelt, maybe you don't. But if you wear it and you get stopped at the random checkpoint, you're not going to get a seatbelt ticket. If that had factored and you didn't try to factor it further, you probably would have missed it. You would have missed 1 out of 5 points on a test because you didn't factor it completely. Anyway, that's the first example. We got 9 to go. Hopefully that one showed you a few things about writing polynomials in standard form, about factoring out a GCF, about looking to see if it factors any further. Okay, so that's the first one. The next one. This is factoring when a is 1. This should be easy. Going to have a binomial and a binomial. Going to have an x and an x. And this is the one, I said it before, and it sounds really silly to say this. It says to be able to factor, you have to factor. To be able to factor, you have to factor. To be able to factor, you have to factor. What factoring means in this case is finding 52's factors. 1 and 52. So can I just plug a 1 here and a 52 here? Not exactly. It doesn't work like that. If I do that, remember foiling, that's going to be 1x, that's going to be 52x. Foiling has to end up equaling the term in the middle, and 1 and 52 surely aren't going to get it done. So I got to keep on looking for factors. My 6th grade teacher said if something's even, divide it by 2. Okay, 52 is even. That's going to be 2 and 26. So I'll just plug in a 2 and a 26. Is that going to work? Nope. That's not going to work either, so I can't just plug those in. A number is divisible by 3 if the sum of its digits, 5 plus 2 is 7. 7 is not divisible by 3, so 3 doesn't go into this. A number is divisible by 4 if 2 divides it evenly. A number is divisible by 4 if 2 divides that number evenly. So this is going to be divisible by 4 how many times? 13, good. So maybe 4 and 13 will get it done. So now I got to look at my signs. That's negative. So my signs in here, one's going to be positive, one's going to be negative. And before I go penciling that in, I got to think, I got to have some planning ahead. I'm trying to make minus 9 in the middle. Trying to make minus 9 in the middle. So with a 13 and a 4, I guess if I go minus 13 plus 4, that'll get it done. Hopefully those ones are a piece of cake, a walk in the park. The hardest part about that one, I think, is that not a lot of people know their factors. Not a lot of people know that 52 is 4 times 13. Maybe card players would know that. If you play a lot of cards, you might know that. Okay, so that's example 2. We are 22 and 2/9% done with the lesson. Example 3, here we go. Oh, geez. And this is why I don't like algebra. Factoring quadratic trinomials when the a value is not 1. What makes it worse is the fact that the a value is not even close to being prime. It is an even number, but it's not prime. It's very composite. It's got a lot of factors. And the constant's got a lot of factors too. So in the grand scheme of things, there's several ways to approach this. You could guess and check. But I got to tell you something, guessing and checking is probably the worst way to proceed with this. Reason being, if you tried guessing and checking, it could be 12x and x, or it could be x and 12x, and it could be 6x and 2x, or it could be 2x and 6x, or it could be 3x and 4x, and it could be 4x and 3x. That's just on that end. And then on the other end, 20. 20's got a boatload of factors too, doesn't it? So it could be 1 and 20, could be 20 and 1, could be 2 and 10, 10 and 2, 4 and 5, 5 and 4. That's a lot of combinations. That's a lot of guessing and a lot of checking. Oh, man. So I'm probably not going to guess and check on this. Now, earlier in the year, we talked about the magic X. We talked about the magic X. The magic X is one of the AC methods. Some people call it the AC method. Regardless, we're going to have to take 12 times negative 20. 12 times negative 20, which is negative 240. Negative 240. And we're going to have to take that number, negative 240, and try to find its factors. The factors of negative 240 that add up to positive 1. And it's probably going to take a long time. Perseverance is something that I can't teach you. I really don't see myself as a teacher. I really see the educational process as a process. And at some point, you have to have a drive within you that says, I want to try to better myself. I'm never going to have to factor a quadratic polynomial in my life, but the perseverance it takes to do that is going to help me in life at some point in time. I don't understand it now, and I may never understand it, and I might not be able to help my child when they have homework problems over this, but I have perseverance to find as many factors of negative 240 as I can until I find the right ones. Negative 240, 1 and 240, 2 and 120, 3 and 80, 4 and 60. Told you it's going to take a minute. 5's going to go into this. 5 goes into 240. That's 4, that's 20, that's 4, that's 0, and that's 8. 5 and 48. Now remember, I want a pair of these factors that add up to 1, and we're getting close. We're getting close, but we got a long way to go. Oh, man. Wow. Okay. Perseverance. Keep on keeping on. 6 is going to work half as many times as 3 did, so 6 is going to work 40 times. 7. I don't know that 7 goes into 240. 7 times 3 is 21. That's a 3 and a 0. No, 7 doesn't work. 8's going to work 30 times. Remember, we want the sum or difference of these two numbers to be 1. We're getting there, but we're still got a long way to go. Still got a long way to go. 2 plus 4 is 6. 6 is not divisible by 9, so this isn't divisible by 9. 10's going to work. 10 and 24. Those still don't add up to 1. Maybe we just quit. Maybe we just give up. Maybe we just say, you know what? It's only 5 points. No big deal. And that's what people do every day in their life with the bank. They need $20, so they go to the ATM, and their bank charges them $2.50 to get $20 out. And the ATM that you go to charges you $2.50. Well, it's easier than driving to my bank, so I'm just going to pay $5 to get $20 of my money out of the bank. And you do that 10 times a month. Next thing you know, you spent $50. You blew $50 because you were too stinking lazy. I almost said stupid. I didn't mean stupid. You were too stinking lazy to drive to your bank or to drive around and find an ATM that doesn't have a fee, to do a little bit of research on a smartphone, by the way, that you have the capability of finding. Perseverance. This is what school's all about. It's not about being able to factor this. It's about, do you have the drive to go as long as it takes, to go as far as it takes to figure something out? That's what school's getting you ready for. It's not about giving you a C in Algebra 2. It's about, can you find these factors that add up to 1? 240's factors, it's got to have them. 12 and 20. We're getting close, but that doesn't work either. 13's probably not going to work. 14 doesn't work because 7 didn't. 15 might. 15 just might go into 240. 5 went into it and 3 went into it, so I'll bet 15 does. 15 times 1's 15. 24 minus 15 is 9, bring down a 0. 15 times something, I think it's 8? Is it, or 6? 15 times 6 is 90. Yeah, 0, yeah. Oh! 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 15 and 16. Took a while. You got to stay after it sometimes. Got to stay after it sometimes. So we want 15 and 16, and we want them to add up to plus 1. So minus 15 plus 16. The way the magic X works now is on these little wings. Does anybody remember this, what we divide by? We end up having to make a fraction. We end up having to make this a fraction, and we're going to reduce the fraction. We're going to divide by the leading coefficient, which was 12. We divide by 12, and then we reduce that fraction on down. 15 divided by 12, those are both divisible by 3, so that we can make that 5 over 4. So negative 5 over 4. And then 16 over 12, those are both divisible by 4. That's going to be plus 4 over 3. And then unpacking this, putting this into our binomials, that was where the weird stuff happens. That's kind of like going to the bank with your ATM card, forgetting your PIN number. Oh, geez, now what do I do? Now I might have to actually make a phone call and talk to somebody on the phone. So we're going to have two binomials. The denominators are the leading coefficients. So this 4 here is going to make 4x. And I think the signs stay the same. So that's going to be 4x minus 5. The other one's going to be 3x plus 4. And if you want to check yourself before you wreck yourself, metaphorically speaking, that's going to be plus 16x. That's minus 15x. It's all good. That's it. That's it. There's our answer right there. Took a lot of work, took a lot of effort, and it will sometimes. Buying shoes. My wife will not go shoe shopping with me to this day. I took 6 months to buy a pair of shoes one time. 6 months, no lie. I was looking for something particular. 6 months. Won't buy shoes online anymore, I know that. Example 4, factors. So this is one of those quasi-quadratics. It doesn't look quadratic, but it factors like one. It's kind of weird because we have an x to the 6th here. If that was x squared minus x minus 42, that'd be a piece of cake to factor. That's going to be an x and a 6 and a 7, minus on the 7 and a plus on the 6. It's going to be easy, right? The only difference is that 6 right up here. 3 in the middle. This one had a 1 in the middle, and this is a 1, and this is a 1. So I bet that has something to do with it. So this is going to be an x cubed, and this is going to be an x cubed. X cubed times x cubed. We had a lesson a couple weeks ago on exponent rules. That's going to be x to the 3 plus 3, which is x to the 6, so that's it, yeah. So we're going to go with an x cubed and an x cubed. X cubed and an x cubed. And then it's just like the other one. 42's factors are 6 and 7, plus on the 6, minus on the 7, and that's it. That's it. How do we feel about example 4? All right. What if that was x to the 8th minus x to the 4th minus 42? Could you have factored that one too? Okay. All right. Well, I said we had 9 examples to get to. We're almost halfway done. Question? So example number 5. Factor completely. Factor completely. Ooh, and I think we're up to the factor by grouping technique. That's where the pattern, I've written it so many times, I don't want to write it anymore, but I will. RA plus RB plus S times A plus S times B. You pair the first 2, you factor out their greatest common factor. You pair the last 2, you factor out their greatest common factor. The 2 things that factored out become one of your binomials. The binomial that showed up twice becomes the other binomial, and that's the general pattern for factor by grouping. Whether something's a candidate for that depends on if it has 4 terms. You need 4 terms for factor by grouping to work. We've got 4 terms. So here we go. The first 2 will factor an x squared out of that. That's going to leave a 4x minus 7. Understanding factoring by grouping realizes you got to recognize patterns. If you work in Cleveland and you work until 4 o'clock, you might recognize a pattern that if you get on the road by 4:05, you could probably get home. But if you stay late after work and you talk to somebody at the water cooler and you leave at 4:40, you're not getting home till 9 o'clock. Because you're going to hit rush hour traffic. Recognizing patterns. That's what math is about. That's what school's about. Being able to apply this stuff to other situations. So we're going to factor something out of that that's going to make a 4x minus 7 again. I know that 4x minus 7 again's got to show up. So I got to factor something out. What do you divide negative 16x by to make positive 4x? What do you divide positive 28 by to make a negative 7? It's going to have to be a negative 4 that we factor out. It's going to be a negative 4 that we factor out. So these two things combine and make x squared minus 4. The other thing that showed up twice is going to make the other binomial. And the directions said very knowingly, factor completely. We're not done. If the directions ever say factor completely, you can probably take it to the bank that 8 out of 9 times you're going to have to factor again. And what we've got right here is one of the ones that's going to show up in a minute. It's a perfect square. No, it's a difference of two squares, which is going to factor into x plus 2 and x minus 2. And then we've got the 4x minus 7. So this whole entire thing is our answer. And that's that one. And that's that one. We're 55% of the way done. 9 examples, that's the 5th one. I hope that this is kind of refreshing your recollection of factoring. What I urge you to do is look at your notes when you're trying the exercises tonight. If there's something you're not quite sure of, look at your notes. Look at these problems. Look to see, hey, it had 4 terms. Maybe I could factor it by grouping. Hey, it had 2 terms, and there was a minus in the middle. Maybe it's a difference of 2 squares. That's what this is all about, recognizing patterns. Here we go. Example 6. This one is the perfect square trinomial. Perfect square trinomials are of the form a squared plus, sometimes minus, 2ab. It's always plus b squared. The nice thing about a perfect square trinomial, we learned this in chapter 4 when we completed the square. They always factor into the square of a binomial. They always follow this pattern. Always. Being able to recognize a perfect square trinomial, that takes a little bit of practice. Being able to recognize a Craigslist scam when somebody wants to buy your musical instrument that you listed on Craigslist. That takes a little bit of practice. Maybe you get burnt once or twice. 16x squared, that's a perfect square. Plus 1, that's a perfect square. The middle term has to be 2 times the square root of the first times the square root of the last, either plus or minus. If it's not, then it's not a perfect square trinomial. Square root of 16x squared is 4x. Square root of 1 is 1. 2 times 4x times 1 is 8x. This is a perfect square trinomial. It does factor the way that I'm going to show you. It factors into 4x minus 1, and that's it. The quantity squared. Boom. Done. Those should be a walk in the park. Those should be really easy. Ever have to take college classes after you get your degree? For continuing ed, they have a saying, pay the fee, get the B. You know, teachers have to go back to school and take so many classes every few years to keep their teaching certificate. And there's a saying, pay the fee, get the B. And there's actually some classes, this is true, you pay more and you get an A instead of a B if you want the A. How sad is that? That it's all come down to money. Anyway, that's a whole another can of worms. Example 7, factor completely. Factor completely. So this one is a difference of 2 squares. And a difference of 2 squares follows this pattern. A squared minus b squared becomes a plus and a minus b. Follows that pattern. So we just got to take the square root of 25x to the 4th, which is going to be 5x squared. And we got to take the square root of 49y to the 4th, which is going to be 7y squared. And it's plus 1 time, and it's minus the other time. The directions very knowingly said factor completely. When the directions say factor completely 8 out of 9 times, you're going to have to factor it again. What ends up happening is this might be a difference of 2 squares. If this happened to be a perfect square and this happened to be a perfect square, it would be, but they're not. So that's about the best you could do on this. Okay. 8 out of 9 times you'll have to factor further. This particular one, not so much. The one on the test, the one on the quiz, you very well may. Watch out for those. Example 8. So this example 8 and 9 get into something that's new, something that we haven't looked at yet, something called a sum and a difference of cubes. Sum of cubes and a difference of cubes. These follow a particular pattern. Sum of cubes says if you have something cubed plus something cubed, you're going to get a binomial times a trinomial. The signs are going to be plus, minus, and plus. A difference of cubes looks almost the same. A cubed minus b cubed. You're going to get a binomial. You're going to get a trinomial. The signs are minus, plus, and plus. Where the magic happens on this is the next step. We're going to take the cube root of a cubed. We take the cube root of a cubed. We take the cube root of a cubed, which is where this a comes from. We're going to take the cube root of b cubed, which is where this b comes from. Okay? That's going to happen on both of them, whether it's a sum of cubes, whether it's a difference of cubes. The stuff in the trinomial, what we're going to do is we're going to take this a and we're going to square that, and that's what gets dropped off right there. When we square a, it's going to be a squared. When we take b and we square that, that's what's going to go on the end. So it's going to be a b squared on the end. It's going to be a b squared on the end. What goes in the middle is kind of weird. What goes in the middle, I'm going to take this a and this b. I'm going to take the a times the b, and I get an ab in the middle there. Get an ab in the middle there. And that's it. That's the pattern. It works. Trust it. Try to apply it. See if you can figure it out. Example 8 is a sum. Example 8, we're going to have parenthesis, 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 parenthesis. Our signs are going to be plus, minus, plus. We got to know the cube root of x cubed. What is the cube root of x cubed? Isn't it x? The cube root of x cubed is x. Got to know the cube root of 27. The cube root of 27. What number times itself is 27. 9 times 9 is 81, so it's not going to be 9. What number times itself is going to be 27? 3? Okay, so it's going to be a 3 here. Remember, when we get to this binomial, we're going to take this this x and we're going to square it, so that's x squared. We're going to take 3 and square it, so that's going to be 9. For the middle, we're going to take these two and multiply them. We're going to take x times 3, which is going to be a 3x in the middle, and that's it. And that's it. Some people might think that that trinomial is a perfect square trinomial. If you do the test, it's not. The middle term's not quite right. Okay? What ends up happening or not happening is this is not a... It never has been and it never will be. It's not going to factor. It's not going to factor. Okay? The last example we got is example 9. It's going to factor into a minus and a plus, and we need the third root of 8x cubed, and that's going to be 2x. When we square 2x, it's 2x times 2x, it's going to be 4x squared. When we take the cube root of 125, it's going to be 5. When we squared 5, it's going to be 25. And lastly, when we multiply 2x by 5, in the middle it's going to give us a 10x. Remember, this is not a pst, never has been, never will be. It looks like one, but it's not. That's it. That's your factoring review. Hopefully it's been educational. Hopefully it's been entertaining. I'm going to end with a knock-knock joke. Knock, knock. Nobody.